All right, so obviously I am a terrible person because this should have been back like January 23rd, 24th. And well, just like all of you guys, life kind of gets in the way. So that being said, welcome to 5-1. Um, Radical notation to rational exponent notation. This first day was pretty easy. Basically, we were learning how to switch from, well, you normally see it as like a square root sign, but we need to really start calling it a radical um, because it's not always going to be square root anymore. And you can kind of see that down here. We got these little numbers, and oh, this one's blank. We'll talk about that actually. But anyway, it's pretty simple. And I will say also, let me get a pen. You could have um, something like this, and it switches to the same thing, but your big number inside is still your big number, and this is a fraction exponent where your numerator is your power here and your denominator is your root. So we started by switching a few of them. It was a nice little reminder that all of these have a invisible exponent of 1. That's where all the ones on top came from. And when there is no number out here, it's like, well, we need that number out here to go on bottom. This is square root. You would write square root, and if it's invisible, it is a 2, where we look for two things on the same on the inside and do it like that. So switching them around wasn't too bad. This formula is stuck up on my board. This is going the other direction, and I took something out here clearly because I didn't like it. So anyway, we went the other direction and wrote them like this, to where the numerator is your power inside and your denominator is your root outside. And switching these around weren't too bad. If this is going too fast, definitely press pause and see if you can't figure out, you know what, kind of figure out what's happening. But there's an invisible 1 right there that we don't have to write because something to the first power is 1. So we rewrote those, not too bad. Then we talked about negative exponents a little bit. And this may go back to like your Algebra 1 days where negative exponents just go on the bottom of the fraction. And honestly, on my board, I don't even have it written like this. I have it written more of a to the negative x, because x can be whatever, is 1 over a to the positive x. So I was like, we're really just worrying about that sign. That sign just goes away when you put it on bottom. So you may want to have this kind of written down somewhere. But once we're here, we can always switch it back to this, is what they did. But obviously a can't be 0. We can't divide by 0. So rewrite using radical notation. And we had these negative exponents. Well, we only did 2 of them. I started with, okay, let's take this and put it on the bottom of the fraction. Now we can look at this, leave the top alone. Now we can look at this and change it to this, which is what we did literally on the last slide. Take this negative exponent, put it on the bottom as a positive exponent. The negative 6 is still just negative 6. And parentheses help here. And then we switch it to that. It wasn't too crazy. I think that might have been all I talked about on the first day. Hold on a second. No, that's totally a lie. I knew I talked more than that. Okay, so evaluating nth roots, and this is where we started breaking it down and really starting to worry about, and I called it a root. I don't call it index. People call it index. If you want to call it index, that's fine. But like I look at it and say that's 4th root or 7th root or cube root or whatever it is. So we did some evaluating. And all we really had to do is take this negative 64 and factor it all the way out. Okay. And if this looks confusing, at the very, very beginning of this playlist is factor and foiling, and you can watch those. But this 4 here on the outside, instead of a square root is normally, oh, we're looking for 2 of the same thing. which is great. But this 4 means we're looking for 4 of the same thing for it to come out. -1, we learned from complex number stuff that it comes out to be I, usually. We'll talk about that. And anything left over, we multiply back together and put under. But make sure you have this guy right here, because without it, you look at it and you go, oh, square root of 4, well, that's 2. And then 2 times, no, hold on. We need this 4 there. It is very, very important, saying we need the 4th root of 4. So we did some more practice problems, I think, on the next page. Yeah. This one, 32, gave me 5 2's. I'm looking for 5 of the same thing. So that all came out to be 2. This one was a little tricky. I said we could do it a couple different ways. But I said, check this out. We rewrite it like we do here. And we could take 81 and make it 81 to the 3rd and make it a super big number. I was like, but if we just need this 3 times, why don't we break down 81 and see kind of what happens? So we did 3 times 3 times 3, which 9 times 9, 81, makes sense. And I'm looking for 4 of the same thing. Well, if 81 is 4 3's, and I have 3 of them, well, then that comes out to be 3 times, which ends up being 27. Then we did this one, square root of 72x to the 3rd. Broke down 72, lined everything out, including x times x times x. And because this was blank, I know there was a 2 there. I'm looking for 2 of the same thing. I found a pair of 2's, found a pair of 3's, and a pair of x's. So 2 times 3 gave me 6. This x came out. And this is where you got to be really careful, because the 2x stays underneath, and we didn't technically need that. But we will start needing numbers here, and you got to be careful where you put this, because if it's over here too much, it definitely looks like x squared, and it's not. So make sure that it's over here with the radical. And this is kind of one of the ones I was talking about, and I'll just kind of pause and break this down. But now we need 3 of the same thing. And so if this little 3, and I'm going to move the whole thing, if it gets too close, to over there, then it can be tough to distinguish kind of what's happening. But this 2 and 5 are the only thing left over, and on the inside. Exponents are pretty easy. How many chunks of 3 can I get from 3? Well, just 1. How many chunks of 3 can I get from 6? Well, I can get 2 chunks of 3 from 6, and that's why it's m squared. Or you could literally list it all the way out. But once it gets into, like, you know, higher exponents, it could be easier just to think like, oh, how many chunks of 3 can, and it's really just divide. Really all it is. So here we go. This is where it gets a little bit different. Lots of arrows, because my 7th hour wanted arrows. So let me do this. Let me pull my arrows just for a moment and talk through this. Actually, can I group those together? Sure can. Let's move the whole arrow. All right. So negative 250 breaks down. Fantastic. 3 5's come out. This 2 is going to stay in there, and we're not even messing with the variables yet. Obviously, that's coming up. But -1 does not come out to be I. Well, why not? A -1 inside of a root, right? Well, here's the deal. With all the even roots, absolutely, because if you have 2 -1s, that's a +1, and the -1 wouldn't exist. But I said, what about this? Can I factor out a -1, get 250, factor out -1, get -250, factor out -1, get +250, and then go here? Do I not technically have 3 -1s that could come out? Ooh, that's the wrong arrow. And so that -1 actually comes out to be a negative, because I have 3 negatives. I can have 5 negatives. I can have any odd number of negatives, because I can just switch back and forth. I start with 1, so 1 could work. 3 could work, because that's just +1. 5 could work, 7 could work, but even numbers can't, because as soon as I have a second one here, then I don't need to take it out at all. That's where, like, the plus or minus kind of comes in. Anyway, the group of 5's, the 2 that's left over, and we pulled the cube root sign. Now let's talk the variables. How many chunks of 3 can I get from 8? How many chunks of 3 can I get from 1? And how many chunks of 3 can I get from 2? Well, we can just list them all out, and I can get 2 chunks from 8, but I have these 2 x's left over. My leftover x's stay inside. I can't get any from y, and I can get 1 chunk of 3 from the 3 that was up there. And that's where this 1 comes in. But again, be careful with writing that cube. Make sure you kind of open this up a little bit more. It'll make things better. So that was all for part 1. Part 2, we're going to introduce some variables, some more variable stuff to it.